Welcome to Click Academic. We will be starting a series on mathematical method. This is lesson 1 and we will be discussing about Roles Theorem. Roles Theorem, we say that before a function satisfies the hypothesis of Roles Theorem must satisfy two conditions. Number 1, the function must be continuous on closed interval a, b. And the function must be differentiable on the open interval a, b. We are taking that interval to be a, b. So if the function satisfies these two conditions, it satisfies the hypothesis of Roles Theorem. Then the conclusion of the theorem said f prime of c is equal to 0. And you are going to find that f of a is equal to f of b. So since f prime of c is equal to 0, this c is a number that exists between open interval a, b. So at the end, if you are to prove the theorem, if the function satisfies the hypothesis of the Roles Theorem, so you should actually find that number that exists between the open interval a, b. For example, number 1, we are given f of x is equal to 3x squared minus 12x plus 11 on interval 0, 4. Now we are asked to prove that this function satisfies the hypothesis of Roles Theorem. Then we should find that number that exists between the open interval 0, 4. Solution. So to see or to find whether this function is continuous or not, we should test the function of this a and b. This 0 is our a and 4 is our b. So we should now find f of a, and our a is 0. Then f of 0 is equal to, anywhere we have x in the function, we should now replace 0. 3 into 0 squared minus 12 into 0 plus 11, which is equal to 0 squared, 0, multiplied by 3, 0, minus 12 times 0, 0, plus 11. 0 plus 0 plus 11 is equal to 11. Then f of b, and our b here is 4, which is equal to, anywhere we have x from the function, we should now replace 4. 3 into 4 all squared minus 12 into 4 plus 11. 4 squared, 16. 16 times 3, 48. Minus 12 times 4, minus 48 plus 11. 48 minus 48, 0 plus 11 is equal to 11. So f of a is equal to f of b, because f of a is 11 and f of b is 11. So since the function, the f of a and f of b, they are all continuous because they are not divided by 0. So once you find that it is not divided by 0, the function is continuous at that particular point. So the function now is continuous. So let's see whether the function is differentiable or not. Can we differentiate the function? We now say f prime of x, that is the first derivative of the function, is equal to derivative of 3x squared, 6x, because you have to multiply power by coefficient, then reduce one from the power, since it is algebraic function. Derivative of minus 12x minus 12. The function, yes, the function is continuous. So since the function, the function is differentiable, since the function is continuous on this point, and the function is differentiable, therefore the function satisfies the hypothesis of Roles Theorem. Then, to find that number that exists between this interval 0, 4, you should, as I told you before, you have to use the conclusion of the theorem, which is f prime of c is equal to 0. Then f prime of c is equal to 0. What is f prime of c? From the beginning to this point, we don't have f prime of c, but we have f prime of x. Since we have f prime of x, now we can find our f prime of c. So anywhere we have x from f prime of x, we should now replace c. So f prime of c is equal to 6c minus 12. F prime of c is equal to this. And remember, the conclusion of the theorem says that f prime of c is equal to 0. This implies this is equal to 0. So this implies 6c minus 12 is equal to 0. So to find the value of c, minus 12 and 0 are like term. They have no c. So 6c, collecting the like term, is equal to minus 12 across equal sign become plus 12. We are looking for c. We should divide both sides by 6. c is equal to 12 divided by 6. 12 divided by 6, 2. So that number that exists between the open interval 0, 4 is 2. Therefore our c is equal to 2. That's all.